think of autumn, maybe one of the first home projects you think of is raking.
But maybe you should start thinking about another project, one that doesn't affect how the house looks, but makes a difference in how it feels.
And in the size of your winter heating bill. Hi, I'm Dean Johnson.
And I'm JoAnne Liebeler.
Weatherization and insulation is a project that most people can undertake. The techniques involved aren't that difficult to master, and the scope of the project can be adjusted to just about anybody's time or budget.
Projects like these often pay for themselves in a few years with the savings in heating costs. And the insulation that keeps your house warm in winter will also help keep it cool in the summer. In this videotape, we'll explain the fundamentals of heat movement and show you where to look in your home for potential energy loss.
Then we'll show you how to perform several projects that should save you energy money. First, we'll weatherize this house to seal up gaps and cracks. Then we'll insulate to slow down heat loss. In the course of the program, we'll show you the tools and techniques you'll need to do high-quality, professional work.
Hometime is made possible by Chevrolet, who brings you full-size Chevy pickups, the most advanced in Chevy history. Chevy S10 pickups, compact, fun, and hard-working. Chevy S10 Blazer, America's most popular sport utility vehicle. Chevy Astro, the van that can. The heartbeat of America. Today's Chevy truck.
This video is just one in a library of instructional programs designed to assist the viewer in working on a wide range of home improvement projects. And before we begin our program, I want to explain how you can best make use of this educational system. First off, you should watch the tape all the way through to get an idea of the methods, the steps, and the terminology we use. To help familiarize yourself with the terms, we've included a glossary in the project guide. Then you should review the tape again, only this time, check with your project guide to determine the tools and materials appropriate to your project. Then take the project guide to your local building supply dealer or home center. The people there will be able to assist you, answer questions, and direct you to what you need.
Understanding how heat travels is important if you want to figure out the best places to insulate your house. It isn't all that complicated. Heat can be conducted through substances that touch each other, or it can radiate from one material to another, even if the two don't touch.
The warm air on the inside of the house heats up the various layers of the wall, starting on the inside. Then the outside of the wall transfers that to the ground and the outside air. That's called conduction. Heat can also radiate away from a house. Just as you can feel the heat from a fire without actually touching the fire, heat radiates away from the side of the house, even if there's nothing touching it.
If you could completely stop heat loss in your house, you could turn your furnace on once in the fall and the heat would stay in the house until spring. Obviously, this isn't possible.
What we try to do is slow down the heat loss, cut down the number of times the furnace runs to maintain a constant temperature. This is where insulation comes in. There are a lot of different types of insulation materials, but there's an easy way to compare them. All these materials are rated on a system of R values. The R value measures the resistance the material has to heat passing through it. For instance, this 6 1/4 inch thick piece of fiberglass has an R value of 19. This 1 inch thick extruded polystyrene board has an R value of 5. A 3 inch layer of this shredded polystyrene has an R value of about 10. And a 3 inch layer of this mineral wool gives R11 insulation. The R ratings for these materials are based on proper installation, so how you install the insulation is just as important as the materials you use.
And how much insulation you need varies according to the climate in your area. Local utilities and state and federal agencies publish guidelines for different parts of the country. There's another type of heat loss that isn't solved by insulation. This is when air leaks through gaps in the house exterior and carries heat out and brings cold in. Now there's a fancy word for this, convection, and you might think it's the simplest type of heat loss to understand, but that's not quite the case. As we know, hot air rises, so the warm air in a house will tend to push its way up inside the house. If there are any leaks in the house near the top, the warm air will seep out. These leaks are called bypasses because even if there's insulation in the house, the cold air current can bypass it. As the warm air rises, cold air will try to seep in from the outside at the bottom of the house. This is called infiltration, and this is where weather stripping and caulking will come in.
Almost all the remedies we've talked about so far are good projects for the average homeowner. About the only insulation project that requires more specialized knowledge than we'll be going into in this program is blowing cellulose or foam insulation into a finished exterior wall. This is really a project that's best left to an experienced contractor. In this tape, we'll begin with those projects that bring big energy savings quickly. Then we'll move on to other projects whose payback is a little longer in terms of time and money. We'll start with caulking, both outside and in. Then we'll weather strip around windows and show you some treatments for doors. We'll start insulating in the attic, show you how to insulate an unfinished exterior wall and how to insulate the rim joists in your basement. You'll find the steps listed in the tape reference to your project guide. It's a good idea to write down the counter number from your VCR player next to each step to help you review.
There are only a few specialized tools you'll need for most weatherization and insulation projects. These include a caulk gun, a glaze scraper, and roof jacks. The tools you need that you probably already have include a hammer, a utility knife, a putty knife, a circular saw, a hacksaw, a tape measure, a pry bar, staple gun, a drywall T-square, a screw gun, a hair dryer, and an electric drill with a hole saw bit. If you're doing any work with fiberglass, you need to protect your skin against irritation. Wear long sleeves, safety glasses, particle masks, and gloves.
These projects involve working over unfinished floors, on ladders, around electrical connections, and around other potentially hazardous situations. So be safety conscious.
We recommend that you work at a comfortable speed, wear the proper clothing, and follow the manufacturer's guidelines in using their tools and materials.
While we can show you how to weatherize your home, Chevy can show you how to weatherize a hard-working truck, like this tough new full-size Chevy pickup.
It's built totally new to be the most advanced full-size Chevy pickup ever. All the exterior panels, except for the cab roof, are made of two-sided galvanized steel. The finish is 7 layers deep. And there's a special anti-chip coating along the lower body side panels.
Like all light-duty Chevy trucks, it's backed by 6-year, 100,000-mile protection against outer body rust-through. That's solid proof of the quality Chevy built into this big pickup.
An 8-foot cargo box is standard on long wheelbase models, so you can carry 4 by 8-foot material flat on the floor with the tailgate closed. Plus, these depressions in the box sides let you insert supports above the wheelhouses for double-deck loading.
To move big payloads, a fuel-injected Vortec V6 engine with 160 horsepower is standard. And depending on the model, you can also get available V8s up to 454 cubic inches.
Inside, there's a whole new interior. And since this is a 4-wheel drive model, InstaTrack is standard. InstaTrack lets you shift from 2-wheel drive to 4-wheel drive high and back again at any speed. You don't have to slow down, stop, or back up. InstaTrack lets you stay in this comfortable cab and shift on the fly.
A feature I like in bad weather is the rear-wheel anti-lock brake system. It's designed to give you smooth stops whether the truck's loaded or empty. On 4-wheel drive models, the system operates only when the truck's in 2-wheel drive.
Chevy's advanced new full-size pickup offers you a lot.
Because it's from today's Chevy truck, the heartbeat of America. In terms of what materials cost and the dollars that can be saved in energy expenses, caulking is one of the most cost-effective projects you can undertake. The basic tool for caulking is the caulk gun. This dispenses caulk from these disposable cartridges. The tip of the cartridge gets cut open to let the caulk flow out. We want to cut the tip on a slight diagonal. On this window frame, I apply a bead of caulk along the edge of the sash stop. Laying a smooth, even bead of caulk is a bit of an art. You need consistent pressure on the trigger and an even movement along the surface. You should caulk any joint between 2 elements of the house, like here between the siding and the window frame. This is siliconized latex caulk. It's good for general exterior work, and it can be painted once it's dry. When you choose caulk, be sure to consider whether you're going to want to paint it later. And some caulks won't work well if you apply them when the weather is too cold. So check the label for this information too.
The seam between the bottom of the siding and foundation is an important place to seal up, as is the joint between the door frame and the stoop, and between the stoop and the foundation. Places where gas, water, or electric lines enter the house can also leak air and should be caulked. This also goes for openings in hose spigots.
Gaps around masonry elements, like the fireplace, are especially important to seal. Any openings in the foundation itself should be caulked. Large openings may require some sort of backing, like this foam rope, before you caulk. This keeps you from trying to fill up a large cavity with caulk. As you can see, caulk doesn't have to be white. This is a clear silicone caulk.
Caulking is important on the inside, too. To demonstrate, we had this device called a blower door installed on the door of this porch. It can be said to either pressurize or depressurize the house. Then we can trace the movement of the air with this smoke pencil. Okay, Randy, let's give it a try. Right now, the house is being pressurized and the smoke shows where the heat leaks out. As we can see, the edges of the fireplace are a place where warm air can escape. The fireplace itself needs to be sealed with plastic for the test. It loses so much heat that it would throw off the rest of our test. We'll deal with that opening later. Holes in the floor where radiator pipes enter are also places that can lose heat. Baseboards are another. Inside, it works well to use a clear caulk. This one comes in an aerosol can, so it's easy to use. This caulk is white when you apply it. This allows you to see exactly where you've put it. It'll dry clear in a couple of hours. The nozzle lets me apply it straight into the gaps around the fireplace. I wipe off the excess with a finger or damp cloth. Here along the baseboards, we're not getting good coverage with one application of caulk. We'll probably want to do this area a second time. It's a lot easier to work along here with the carpet up. The same holds for sealing up these radiator pipe holes. It's a lot easier if there's no carpet. Again, we fill these holes with foam filler rope. This just fills up the cavity so that we're not trying to fill it up with caulk. We use caulk then to seal along the top of the opening. And it's very important to seal around the window frames.
When you stop and think about it, the only thing that keeps the heat in the inside of the house from going up the chimney is a metal damper. Metal doesn't offer that great a resistance to heat transfer, and when the damper's closed, there are usually a lot of leaks. So we built a fireplace plug to fit in the opening when the fireplace isn't in use. It's made of 1/2-inch plywood that we've backed with polystyrene insulation. We made the plug just a little bit smaller than the opening. We'll fill this gap by attaching vinyl V-strip weather stripping along the edge of the panel. This has an adhesive backing. We'll be using more of this when we weather strip windows. We cut a 2x4 to fit into the opening near the bottom. The plug fits snugly into the opening, and the weather stripping fills any irregular gaps around the edges. Once you've built the plug, you'll probably want to decorate it. Painting, stenciling, or wallpapering it will make it quite a bit more attractive.
Caulking helped us seal up many of the cracks and gaps between the structural elements of the house. But there are a few of these elements that have cracks and gaps within them. Well, doors and windows, for instance, because they have to move, have a lot of places where cold air can infiltrate and warm air can leak out. Fortunately, there are a variety of materials that can help seal up some of these cracks and gaps. Together, they form a class of products known as weather stripping. Because materials wear down and decay and framing can shift slightly over time, even a well-designed window can start leaking air after a few years. This is where weather stripping comes in. For instance, at the bottom of the sash of this double-hung window, there are small gaps between the sash and the sill. Our smoke pencil test dramatically shows this. I can seal up the bottom with a thin strip of foam on the bottom of the window. This foam is moisture resistant and has adhesive on one side to attach it to the window. When the window closes, the foam compresses, except in those areas where there are gaps. The foam stays slightly expanded here to block the airflow. Now, the sides of this double-hung window are another matter.
The sash slides along the side of the window frame, so if we put in the same type of foam strip here, it'd just get torn. So we'll be using a strip of vinyl that folds into a V. To make sure the adhesive really sticks, I clean any grease off the surface where I'm going to attach it with alcohol. After creasing the strip, I measure out enough to run along the side of the sash and cut it to length. Now I stick the strip onto the window frame where the sash runs up and down on the side. I only need to start it a little bit above the bottom of the open window. I install it with the V opening out, and I place it close to the parting stop. When the window closes, it pushes the two sides of the V together. Notice that the V opens toward the outside. Any draft coming in will tend to push the V further open, helping even more to block up the gap. The weather stripping should go on both sides of the sash. You'll probably need to jockey the sash from side to side to make an opening for the strip. It's a good idea to work the window up and down a few times once you've installed the weather stripping. This works it into place and lets you see if it's going to bind anyone. It's also possible to staple the weather stripping to make sure it doesn't pull loose. Just pull the vinyl back and drive in the staples. Because of the angle of the gun, the staples might not go in all the way, so we need to hammer them down. Another place on a double-hung window like this where cold air can penetrate is the pulley. The gaps around the pulleys can let cold air in through the weight pocket here in the window frame. The smoke pencil test shows us that this is a spot with a potential for big heat loss. There's a device called a pulley cover that can seal off this spot. It has an adhesive strip on the back to hold it in place. It slips around the sash cord and over the pulley. It also has holes for screws. The window should open and close normally with the seal in place. However, the seal will keep the window from opening all the way. If you want to take these off in the spring, you can leave the protective strip on the adhesive and only use the screws.
A door is another moving piece where a lot of air can infiltrate. Weather stripping along the tops and along the sides can help seal up any cracks in these edges. This door already has brass weather stripping. This works the same way as the vinyl V-strip, and it seems to be working pretty well. So if it ain't busted, we're not going to fix it. However, the bottom of the door is often a trouble spot. Regular weather stripping won't work here. So we're going to attach this flexible rubber seal on the bottom. It has an adhesive side that fits up against the bottom edge of the door. When the other side folds up next to it, it creates a bulb that seals any gaps along the bottom. This side gets screwed in, starting from the center and working out to the sides, adjusting it up and down to make the bulb the right size at each point along the door. There, an easy solution to a common weatherization problem.
Another way to seal this door is to install a completely new threshold. Now, this isn't a difficult job, but it does require a little carpentry. You'll probably have to remove the door to do this. Just pop the hinge pins and take the door out. Prying up the old threshold might get a little messy. This one comes up in two parts. First, I remove the old brass weather stripping. Then I use a pry bar to remove the wood, peeling back the weather stripping on the door frame. It's also possible to cut the threshold in the middle to make removal easier. The new threshold needs to get cut to fit into the doorway. One cut gets it to the right overall length. A hacksaw cuts through both the wood and the metal. Now I mark where the door stops will need to fit on the ends. Then I use a hacksaw to cut out the notches. To install the threshold, I apply a bead of caulk to the bottom. This will also help to prevent drafts. Then I set it in place. It should go pretty much where the old threshold went. A couple of screws secures it down. This threshold comes with a vinyl insert. It slides into these slots. Because this threshold is higher than the other one, we'll have to trim off the bottom of the door. To determine how much to cut off, I'll measure from the bottom of the hinge on the door jamb to the top of the vinyl insert. I repeat this measurement on the door itself and use a drywall square to mark this level off across the bottom of the door. This threshold works best if we put a bevel on the bottom of the door, so I adjusted the circular saw to cut it at a slight angle. The door should be 1/8 of an inch shorter on the outside than it is on the inside. Notice that I've clamped a piece of wood to serve as a guide for the saw. This means I'll get as straight a cut as possible. Now the door goes back on its hinges. As the door closes, the bevel on the bottom pushes the vinyl down a little to make a perfect seal. Another way of effectively dealing with leaky doors and windows is clear plastic. It's a temporary storm window that you put up in the fall and remove again in the spring. And it's something that can be used either on the inside of the house or the outside. The interior plastic is mounted with a double-coated tape. After cleaning the molding, I place it around the edge of the window frame. It goes all the way around the window, including under the sill. This tape is designed to peel off in the spring without pulling any paint or hurting the finish. The protective liner then peels off, exposing the sticky back of the tape. Now I place the plastic over the window. I start at the top. Then I do the bottom and sides. I want to get the plastic fairly smooth, but not too tight. I don't worry about any small wrinkles now. And if I want, I can lift the plastic off the tape and reposition it. With the plastic in place, we'll double check to make sure that it's sealed all the way around. And now to make the window smooth. The plastic shrinks as we heat it, so we'll be using a very complex, highly specialized instrument to finish off the job. This hair dryer will shrink the plastic to a clear, smooth surface. It only takes a few passes over the plastic. You don't want to get it too hot or you'll melt the plastic. Just heat it until any wrinkles disappear. The last step will be to trim the excess off the sides.
If you don't like the idea of putting the plastic on the inside, you can also put it on the outside. The tape goes on the same way. But this exterior plastic doesn't shrink, so we'll have to put it on a little differently. Notice that the tape is applied here to the surface of the frame, not the edge. As I put this on, I stretch it out a little so there are no wrinkles. There's a little give in the plastic, so this isn't too hard. Like the inside plastic, I start at the top and then go to the bottom, working from the center to the sides. The fact that you can lift the plastic off and reposition it makes the job a lot easier. I work up the sides, pulling out a little as I go. Once the whole window is attached, I trim off the excess plastic. I do this by lifting the edge up and away from the window so I don't have to press the knife into the wood of the frame.
When glazing gets old and cracked, it can let air seep in around the window panes. So reglazing is a good step in weatherization. First, I clear out the old glazing. You don't have to scrape it out of every pane, just those sections that are cracked and loose. Make sure you sweep out all the old glazing and any dust before you reglaze. Then put in new push points anywhere the glass is loose. These small metal pieces hold the pane tight against the frame. You should work glazing compound around in your hands before you use it. Then roll it into a thin snake. Work this in along the edge of the pane. Then I hold a putty knife at about a 45-degree angle to the glass and pull it along to smooth out the glaze and trim off any excess. In the process of reglazing the windows, you'll also want to replace any cracked panes because they'll also leak air.
So far in the program, we've been dealing with sealing up leaks, or weatherization. The techniques we've shown you for caulking, weather stripping, and sealing up doors and windows should be applied all over the house.
If you don't feel like weatherizing your entire home, anything you can do will help, but especially concentrate on working from the top of the house down.
Now we want to move on to another topic, insulation. And for this, we'll also be working from the top down. When you start thinking about insulation, you should start thinking about your attic. Because hot air rises, one of the prime trouble spots for heat loss is the top of the house, and attics are usually under-insulated.
When this house was first insulated, energy efficiency wasn't as important as it is now, so 5.5 inches of rock wool was considered enough.
However, it isn't enough now, and the insulation is settled, which further reduces its R value, so it looks like more insulation is the order here.
But before we insulate, there's two things we have to consider: sealing up bypasses and installing venting.
Remember, hot air will tend to leak out of the top of a house. If we insulate the attic floor, we want to stop the air leaks here, too. Since we're on the outside of the house thermal envelope, we look for places where wind coming up from the house blows the smoke around. For instance, here around the base of the chimney. Below the chimney, there's also a bypass at the top of an interior wall. You can almost always find a bypass where the plumbing waste stack vent comes up through the attic floor. And electric cables often let air in around them too. However, the biggest heat loser in this attic is this gap between two interior walls. There's an enormous warm breeze coming up here. If you can't find a firm to do a blower door test for you, you should still be able to find many of the bypasses yourself. One trick is to look for any darker or discolored sections of insulation. The air rising from the house carries dirt and dust up from the inside. Over a long time, that can really show up, even in a clean house. So before we do any insulating, we need to seal up these gaps. And we'll use a lot of the same techniques we used for weatherizing the exterior of the house, like caulking around this electrical entrance. You'll probably need to use something to work the caulk into tight spots. A piece of scrap wood is fine for this. Next to the chimney, we need to use special high-temperature materials. This is a special chimney caulk. Drywall mud will also work for this. Anything that resists high temperatures and isn't flammable. If we've got big gaps, like the opening between these second floor walls, we can seal them up with pieces of loose fiberglass insulation wrapped up in plastic. This not only seals the hole, but it adds insulation value. We seal around the edge of this poly pillow with caulk. The board next to the opening is the top plate of a wall. Sealing along the other edge of this piece will probably also stop some drafts. When in doubt, seal it. You should be as thorough as you can in sealing up bypasses. Always lay boards and pieces of plywood on top of the joist to walk on. Never step between the joists. Otherwise, you could very well end up in the second floor bedroom.
Now here's a common problem: heat loss through an attic access. To cut down the amount of heat loss coming up through the opening, we're going to frame in a trapdoor and install that before we insulate. First, we built a frame up around the opening. It's made of 2x10s and it sticks up into the attic. You'll see later that the insulation will rise level with the top of it. Now we install 1x3s all the way around the inside for the trapdoor to rest on. We screw these into the frame with drywall screws.
Here, I've got it for you.
We cut the door out of a piece of 1/2-inch plywood with a 2x4 frame. The door helps us square up the frame. Now we can screw the frame down. flat hinges screwed in from above will secure the door. We install caulk along the outside of the frame and weather stripping on the inside. We don't want to block the big opening and still leave smaller ones.
Now that we've sealed up the attic so air can't get in from the house, it's time to unseal it so air can get in from the outside. We're going to be installing vents in order to prevent ice dams. Ice dams form when warmth in the attic melts snow near the top of the roof. The water starts to run down the roof. But before it gets to the end, it freezes up because the part of the roof over the eaves that isn't warmed by the attic is still cold. This ice dam causes more water to collect near the edge of the roof. Eventually, this causes the roof itself to rot and decay. The solution is to keep the air in the attic above the insulation cool. And we do that by installing vents near the top of the roof to let warm air out and near the bottom of the roof to let cold air in. The rule of thumb is that you need 1 square foot of vent space for every 150 square feet of attic floor. Now for our attic, that means about 6 square feet of vents, and we'll divide it evenly between the top and the bottom. This roof vent has an opening of 1/2 square foot, and we'll be installing 3 of these near the peak on the outside of the roof.
This box that runs along the side of the house is called a soffit. The underside is the perfect location to install our intake vents. The vents we'll be installing require 2.5-inch holes. I drill them with a hole saw. They're placed about every 2 feet along both sides of the house. The wood here is fairly soft, so the teeth in the saw clog up and have to be cleaned out every once in a while. Once the hole is cut, the vent just pushes up. It has knobs on the side that hold it in place. Before you install these vents, you should make sure that the soffit opens up into the attic. Drill a test hole and check up under the eaves in the attic to see if you can see any daylight. We'll install our exit vents near the peak of the roof. To locate the vents, we pounded nails through the roof midway between the rafters for each vent so we'll know where to cut our openings. We drove the nails up from the inside to give us a reference point on the rafters.
Okay. The vent opening needs to be 8 inches wide. So we measure out 4 inches on each side of the nail and mark it. We'll also measure down 10 inches for the length of the vent.
Now I start sawing. I need to start with a plunge cut. This first cut for the top goes right up along the bottom of a course of shingles. It might take a little work, but the plug should just pull right out of the hole. The vent will fit up under the upper shingles and overlap the lower ones. And I have to remove any roofing nails that get in the way of the flange. Then I nail the vent in place with roofing nails through the holes in the flange. A properly installed roof vent shouldn't require any extra caulking or sealing, and the heat of the sun will cause the shingles to settle back down and seal to each other. When working on a roof, you want to be very careful. It's a good idea to rent a few of these roof jacks to support you. Because they fit up under the shingles, I need to unseal a few of the shingles with a pry bar. Older shingles can be brittle. If you break one, glue it back in place with roof cement. The 16-penny nails that support the jacks go up under a course of shingles. Then a 2x6 goes across to provide a foothold.
There are other types of vents that can be used besides the two that we've just shown you. This is a continuous ridge vent, and it would be installed at the peak of the roof. It would take the place of the 3 separate roof vents we used. There's also a continuous soffit vent that would replace the circular ones we installed. Soffit vents come in other sizes and shapes, too. This turbine is an exhaust vent. The outside air spins it, and that pulls more air up from the attic.
To ensure that the air that comes up through the soffit vents can get up into the attic area and out the roof vents, I'm installing these cardboard baffles. The baffles will keep the insulation away from the roof, and they create this passage for the air to travel up and into the attic area. These cardboard baffles just staple in place. They're also available in plastic and styrofoam. When buying these, be sure to specify whether your rafters are 16-inch or 24 inches on center.
Now we're ready to start laying down insulation for the attic. This is unfaced fiberglass insulation, and these 6 1/4 inch pieces have an R value of 19. But in order to get the R value we need up here, we're going to put down 2 layers of it.
First, we cut some short pieces to fit in the stud cavities on the end wall. To cut fiberglass, I set it on a piece of wood and lay a board across the insulation to compress it. Then I run a utility knife along the edge of the board. Fiberglass is just that, spun glass. The fibers get in the air and can irritate your eyes, throat, and skin. So always wear goggles, a particle mask, and gloves when working with it.
We cut these to 12 inches so that they stick up about 6 inches above the joists. Our 2 layers of insulation will come up to about the same height. Already you can see that it requires a little ingenuity to get insulation to fit around obstacles like this knee wall beam. I just cut pieces to the right size and shape and work them in however I can.
To lay the first full blanket, we tuck the end in under the eaves between the floor joists. A long wood stick is helpful for this. This knee wall is kind of unusual. We have to trim the pieces to fit. The scrap goes under the eave between the next joists. I butt another piece up and continue the process. Okay, Joe, I'm all set for another one here. Okay. This fiberglass comes in 8-foot-long bats. The same fiberglass also comes in rolls. The bats are easier to handle, but the rolls mean less cutting. It's always easiest to start under the eaves and work toward the center of the attic. This way, you're not always trying to cut pieces to fit where you don't have any headroom to work in. Okay, you got another one there?
Once we've got an 8-foot wide area covered, we go back and lay our second layer, perpendicular to the first. We don't want all the ends of all the bats to fall along the same line. This makes a thermal weak spot in the insulation. So we start some rows with a shorter piece of scrap insulation and let some of the rows run long or short. We'll fill in the overlaps when we do the adjacent area.
Before we do the center area, we insulate the other side. As always, we start under the eaves and work toward the center. Here, I need to cut a slit to fit around this electric cable. If we had found any recessed light fixtures, we would be careful not to cover these with insulation. This might trap heat from the bulb and create a fire hazard. It's open under the knee wall on this side, so I can run the bat underneath it. Then I score the insulation with a knife along the side of the beam. This way I can fluff it up to its full R value.
Oh, great.
Then we start with the center section. Again, we lay our first row between the joists, parallel to the end wall. We trim it to length and fit it around any obstacles. Notice that we caulked on both sides of the top of this partition wall. A really thorough job of sealing up potential bypasses is probably worth as much as an extra layer of insulation. Once you've got the hang of it, insulating goes pretty quickly.
"12 inches of insulation may be more than you need for your attic. Check the map in the project guide to see what R value is recommended for your area. Or you can check with your local utility company or state and city agencies.
Once you're done, make sure you don't overlook the last possible source of under insulation. This trapdoor, which is keeping drafts from coming up into the attic, also has to be insulated. So what we did was glue a piece of polystyrene insulation to the top of the door, added a 6-inch bat to give us an R rating comparable to the rest of the attic. This wall between the kitchen and this garage had some water damage from a leak in the garage roof. And water can cause some materials, like this old-fashioned hemp, to lose their insulation values and start to decay.
So we thought this would be a good time to tear out the old drywall, rip off this old insulation, and re-insulate with fiberglass.
Here, Joe, I'll help you with this.
Alrighty. The wall to the kitchen is old-style plaster and lath. As always, before we insulate, we'll seal up any cracks or obvious gaps where air might leak through.
This is similar to sealing up attic bypasses. So we look for the same trouble spots. For instance, the cavity around these electrical cables needs filling. Here I use wads of polyethylene plastic and caulk over and around it.
For this cavity near the sill plate, I fill in with bits of fiberglass insulation and then use an expanding urethane foam.
We use similar techniques to fill this space next to the plumbing. I use the fiberglass to insulate above where we're working, and then use the poly pillows and caulk to seal off any drafts.
We'll be using faced fiberglass insulation here. It has a craft paper backing on one side, and the backing serves as a vapor barrier. Now you'll hear that term used a lot when you're dealing with insulation, and here's what it means. During cold weather, as warm air moves from inside a house through the insulation to the outside, it cools off. This means that the moisture in the air will condense. If it condenses in the middle of the insulation, it reduces the R value of the insulation. And although the insulation itself won't rot, the wood framing around it can be damaged by the moisture. The solution is to install a vapor barrier on the warm side of the insulation. This prevents moist air from traveling into the insulation. Now, the golden rule of vapor barriers is that the vapor barrier always goes on the side of the insulation that's warm in winter. For us, that means the backing will go toward the kitchen, and the unfaced fiberglass in front goes toward the cold garage.
Here, I'll stuff this up here. This insulation is 3.5 inches thick, the same thickness as the 2x4 studs. This means that we're putting in as much insulation as possible, given the thickness of the wall. It's the air pockets inside the fiberglass that make it a good insulator, so we try not to compress it as we install it. The insulation comes in rolls, and the craft paper is perforated at 94-inch intervals. This is the exact length of a standard stud cavity, so that makes installing it a lot easier. Now you'll notice that the insulation fits into place without any fastening. However, on the back side, there are stapling flanges. If we were installing the insulation from the inside, so that the vapor barrier was towards us as we put it in, we'd be able to fold out the flange and staple it to the studs. Now, if this were the warm side of the wall or the inside of the house, we'd have to cover this paper vapor barrier with a non-flammable material. Now, usually this isn't a problem because typically we'd want to drywall the inside of the house anyway.
Another vapor barrier that can be used is polyethylene. Now again, if we were working from the inside out, we could just take this sheet of clear plastic, spread it across the wall, and staple it in place. However, if you're going to be working on an outside wall, you need to cut the polyethylene to fit into each stud cavity. First, we run a bead of caulk around the inside.
I'll center it down here.
The plastic goes into place against the warm wall. The caulk seals the plastic into place, and staples help secure it.
Sorry.
Now we can install unfaced insulation because the polyethylene acts as a vapor barrier.
Okay, Here, if you want to get that up on top. Feed it up to here. Okay, all the way up. Find down here in the bottom.
Okay. Now you may wonder why we didn't install a vapor barrier up in the attic. Well, we did, sort of. There's already a good moisture barrier in place on the underside of the ceilings. Paint can actually slow down the flow of moisture. So by using a low, perm-rated paint on the second floor ceilings, and by thoroughly sealing up any of the attic bypasses, we've already created our own vapor barrier. If you want more information about vapor barriers, just check the project guide.
It's a good idea to cover any open areas of fiberglass that face a living or working area. We'll be covering this garage wall with 5/8" drywall. Okay, you want to set it down there? Okay. To cut it to size, I score it with a utility knife and snap it apart. Then I cut through the paper on the back. We have to cut the pieces to fit around doors, electrical fixtures, and beams. Okay, slide it over. Perfect. Your end up. Then it screws into place on the studs with drywall screws.
Go ahead.
All right. This is fire-resistant sheetrock, which is often required by building codes on the wall between a garage and a house. On a finished wall, we'd seal up the seams with tape and mud. There are other techniques and tools for doing a beautiful drywall job. If you're doing an interior wall, you might want to look at our drywall videotape.
Here in the garage, our local building code only requires that the sheets have no large gaps between them, so no taping is necessary.
Okay, that's the last one. Well, that pretty well wraps up the wall of the kitchen. Last year it was one of the coldest rooms in the house. This year it should be quite a bit more comfortable. And the steps we showed you in insulating this wall would apply to any unfinished wall.
You just need to remember whether or not you're working on the warm and winter side, and then place your vapor barrier accordingly. Well, we've shown you about insulating the top of a house and the sides of a house. Now let's talk about insulating underneath a house.
One section of the house structure that's almost always overlooked for insulation is the rim joist. In most houses, it's the thinnest part of the shell of the house, usually about 1.5 inches wide, and runs around the top of the entire foundation. 1.5 inches of wood has an R value of less than 2, which makes it a prime candidate for insulation. And again, before we insulate, we'll caulk. We seal up the joint between the rim joist and the sill plate. In many homes, as you can see here, there's already a fiberglass sill sealer between the foundation and the sill plate. Each of the gaps between the floor joists is 15 inches wide and 9.5 inches tall. So it's pretty simple to cut a lot of these pieces to size. The pieces go in place without any securing. When we get to this side, we cut a long strip to fit into the gap where the joists run parallel to the side of the house. This is a tough spot to get into sometimes, but if you can get your hand up there, you can squeeze the insulation into place. Once the rim joist is done, we pretty well insulated all the areas of the house that we can get to.
I guess you could say that preparing your house for winter is kind of like dressing up for cold weather. Weatherizing is like closing up any spots where cold air might get at your skin.
And insulating is like putting enough layers of clothing on your body so the heat doesn't escape faster than the body can replace it.
Oh, it is cold today. We finished up just in time.
Looks like it. We weren't able to cover all the situations you'll encounter in weatherization and insulation, but using some of the principles we've shown you and a little common sense, you should be able to apply those to other situations.
Your local utility company or state and city agency should be able to help you. Often they'll come out to your home and give you a free energy audit.
And be sure to check out some of our other Hometime titles.
And watch for the PBS version of our show. I'm JoAnne Liebeler.
And I'm Dean Johnson. So long.
Hometime is made possible by Chevrolet, who brings you full-size Chevy pickups, the most advanced in Chevy history. Chevy S10 pickups, compact, fun, and hard-working. Chevy S10 Blazer, America's most popular sport utility vehicle. Chevy Astro, the van that can. The heartbeat of America. Today's Chevy truck.